Okay guys, I'm going to try to show you how to use Akabak today. So I'll start from the Fusion file and show you how to get it from here to something you can use for Akabak, and then show you how to set up Akabak. We're going to do a real basic infinite baffle situation, just so you can start playing with waveguides without having to learn all the little things from the get-go. And once you get started, it's easier to figure out tricks and the more complicated stuff, but this software can be really intimidating just not knowing where to start. So that's where I hope to help today. Get you started, give you something you can use, and then you can figure out how to use it in more advanced ways later. So what we're going to use is a quarter model of the Waveguide, which I have here. Here's the whole thing put together. That's just made off copies of this using mirroring to move it around there. But you need a quarter model for Akabak to save solving time. If you try to do the whole thing, it's just going to take way too long to solve. So do a quarter at a time and it will save you a lot of time. So your model needs to have a couple extra things added to it. This top box portion is called an interface. It's going to help Akabak solve it. And then I've added a disk here to use as my compression driver. So I'm just going to use this to create a flat wavefront to drive the horn. I also on this one have an added chamber down in here and another source I can use as a compression driver. This is just to replicate the exit chamber of my compression driver to see if it adds any resonances or whatnot. So that's all that is there. So when you've got your Fusion file made up, you're going to go to File, Export, name it whatever you want, and export it as a step file and send it to some place you can find it easy. You're going to use the program Gmesh to take that step file and make it into a mesh like this. So I'll just minimize this all down to kind of what you'd be starting with. So it kind of starts off looking more like this. So go to File, Open, and open your step file. Yeah, that's fine. We'll use this version. This is a bad version, but that's okay. And you're going to start off by clicking Geometry, Physical Groups, Surface, and we're going to actually label all these surfaces so Akabak can sort them out later. So you can name them whatever you want. I've got this one named Interface. So you type the name of what you want it to be, and then you select them. And you have to exit out and click E. And it'll ask you if you want to create a new geo file. Click yes. I've already got one of this. I'll replace it. And then we move on to the next thing. So I'm going to do my horn walls. You have to type it in first. If you do the order wrong, it'll mess things up and you have to go back and fix it. I'll click all these surfaces, exit out, click E. I'm going to call that CD for compression driver. I'm going to call this one CD2. Once you're all done, press Q. That finishes it all out, exits you out of that surface mode. And we're about to mesh it, but first I want to show you my settings. If you go to Tools and Options, click on Mesh, and in the General section here, I've got it set up for Mesh Adapt, element size factor of 1, and minimum element size I've got set to 2 right now. That just limits how fine it can get. In the advanced section, I've got these 3 things checked, and number of elements for 2π is set to 12. I'm using that to create a more dense mesh area by this section by the throat where all the complex curves are really tight. It works out perfectly because that's where our short high frequencies are that are really sensitive to all the small changes. So I want to model that as close as I can. So if you open up mesh, you're going to click mesh 2D, and you can see I've got much smaller triangles down here, and then I've got bigger ones where they don't need to be fine, and that's going to help with our solving time. The more triangles you add in here, the longer it's going to take to solve. When I first started doing this, my models were taking about 2 hours on this computer to solve. It's a i7 with a base 2 gigahertz speed and 16 gigabytes of RAM, and yeah, it was taking 2 hours. I've got it down to about 2 minutes now by messing with these settings mostly. So you've got that. You're gonna export that, so file export. Just make sure you type .msh and save. I would have this one saved, so it'll ask me to replace it. Sure. Save it as version 2. I don't know if Akabak does other versions. I know ABAC only will do version 2. And now we're ready to put it in ABAC or Akabak. So here's where you're going to start out, and I'll show you where we're going to end up. So this is the one that's all set up already. You can see we've got our mesh file here, and we've got subdomains and elements, and you'll see what these are because I'm going to show you how to put them all in there. It's not as complicated as it initially seems. Okay, so we're going to start by putting our mesh file in here. Go to the General tab, double click, and you'll get this list of options you can stick in that area. And for each of these different tabs, they will show you what options you have, what you can insert there. So in the general, we're going to add our mesh file right here. Go to File, Open our mesh file. In general, you can name it whatever you want to name it. That's like in ABAC, if you use ABAC mesh file alias. So it's just naming that file. You can insert a whole bunch of files, and this is just how you differentiate what's what. Go to scaling. I'll just show you. If I hit apply here, I'll show you the drawing. And then here's the deal with scaling. You have to make sure you input the correct units. So in my case, it's 1 millimeter. If I set it to 1, it's going to be wrong. It's going to be way bigger than it should be. So you can see how much smaller it is now that I changed it to millimeters, which is correct. In the drawing section, just go in and select all the pieces that are supposed to be there and the ones that aren't. I'm going to leave that exit chamber out in this one just for simplicity's sake. When you're all done, everything's set up, click apply and close it. Now I'm going to go over to the BEM section. Notice it didn't come up on our main screen here. It's only going to once we tell it it's supposed to be there under the BEM section. So I'll double click in that blank space. It'll tell me the things I can insert. So you need to start with subdomains, which is like areas of air. So double click on that. You can see we've got two different types, interior and exterior. So we're going to use interior as the inside of our horn, and then exterior as the air outside of that. So we'll need a couple of different subdomains in this example. Apply, close. You can see it popped up over here when I clicked apply. You need another subdomain. Here we go. And we need that one to be exterior. Apply, close. Okay, and we do need an interface that will let it interact between the two subdomains. So you need to select 1 and 2 so it knows to transfer between the two. Okay, and now we can start adding elements, which are pieces of our mesh file. So I'll double click on elements mesh file. It's the only one we're going to use today. I'll select the subdomain that this element is going to interact with. So I'm going to start just with the compression driver. And it's going to bring up this screen. And in the drawing section, we can select what parts we're including. So and you can zoom in and move yourself around, make sure you're selecting the right things here. In my case, I know that my little disc is labeled as 1. If it's facing the wrong way, you can use this swap normals button. The side that is reflective, it's reflecting sound waves, is the solid side. If you can see through it, that means it's affecting the other direction in space or something like that. Click apply and it'll pop up in your main screen here. Now I do have an extra step for this compression driver part because it's going to be driven. So if you go to boundaries, just click driven, apply, it turns red. That tells it that that thing is making sound. Let's add some more elements. I'm going to add the horn walls to subdomain 1 now. So again, I already know which of these I need to click on, but just play with these. Make sure you've got everything you need there and none of the things you're not supposed to have there. Click apply and it's going to pop up in your main window here. I've got to add my interface still, and I'm going to assign it to interface. That is 2, 7, and 8. Whoops. Akabak has it's kind of, it almost seems more flexible than ABAC for assigning things. It's a little easier here. Click apply, it's going to show up. Notice the interface faces back into the horn. That's kind of important, I think. The last thing I need to add is, in this case, an infinite baffle, because what's going to happen right now is the sound's going to come up to this edge, and this is literally a 0 edge. It doesn't have any thickness in space, so it's going to cause crazy diffraction. So you can either model your box or your baffle, or you can just use an infinite baffle, which is what I'm going to do here. So double click infinite baffle, and I'm going to assign it to subdomain 2, which is our exterior. Now it's going to ask where or how the infinite baffle is aligned in space. So if you zoom way out, whoops, I've got to apply. If you zoom way out, you can see where the infinite baffle is aligned. And I need it on my Z plane, like so. Okay, that's it for the BEM section. Now real quick, I'm going to go ahead, go to global. There's a couple things you need to do here. The first one is if you click on BEM parameters, that's when you can create the symmetry. Make sure you're on 3D mode, and I can't remember which way I need to do this. Let's just guess. Yeah, XY. Now I have my whole model showing, and it will just copy the calculations over for each quadrant and save you calculation time. The last thing to do is to go into global again, click frequencies, and tell it what frequencies you're going to solve for. I'm going to do 500 to 20 kilohertz. 24 points is fine for now. Then if you go up here, click frequencies, it'll actually tell you all the frequencies you're going to solve for. Now the last thing you need to do is go to the observation section and tell it what you want it to output. So if I double click on that, you get all the options of things you can observe. And for this, I'll just make a polar of the horizontal response for you. So I'll double click on polar, and now you need to assign where it's listening to. Go to position. And my brain's a little dead today. Let's see, not that one. I don't feel like thinking spatially right now, so I'm just gonna guess. There we go. Okay, so there's our horizontal plane. You can see it shows on here if you weren't paying attention. Back in parameters, I like to normalize my results from the get-go. It will automatically normal it to 0 degrees around the z-axis here for me. And then if I want to normalize, like make my response flat at 15 degrees or something, see what that does for me, I'll do that later in VAX. I don't want to do that from the get-go. So anyways, so we've got that, and then you could make another one for your vertical. You could add fields to where you can see the radiation patterns if you want, and so on and so on. So at this point, once you've got an observation file, you can say or solve the system. It should go pretty fast here. Make sure you download VAX. I don't know if it automatically downloads with Akabak. It's been a while since I got these things, but make sure you have that from the same maker. Okay, it's solved. I think I'm going to get rid of this one just so I can show you. I think it's the same waveguide that I'm doing right now. And now this button here is what's going to solve the observation, or the one that outputs to VAX anyways. If you were doing fields, you'd use this button here to solve those fields. And now when I click on VAX, you can see it's exported here. Now you can go in and see what your frequency response is like. If you want to save a curve, I think you like double click or something on it. There you go. And you can save the curves at different places. Oops. That's something I didn't know how to do at first, but now you know. That's pretty much it. I hope this video is helpful and gets you guys started in this. Really, once you get the basics, it's not hard. It's totally doable for normal people. I'm not a computer guy per se. Just took me a little time and some help from other guys. The German ABEC thread helped me out a lot. But yeah, this is totally doable and you guys can use this. So good luck.